we are going to solve simultaneous linear equations using Gaussian elimination method. This method involves forming a matrix called augmented matrix. So by so doing, we have an augmented matrix. Here you have 2, the coefficient of x, 2, the coefficient of x here is 1, here is 3. The coefficient of y here is -1. The coefficient of y here is -2, -1. The coefficient of z is 2, 1, 2. Then dot 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 10, 8, 11. So what we have here is an augmented matrix. Now from here, the goal of the Gaussian elimination method is to have a 3 by 3 matrix where all the elements on a major diagonal will be equal to 1 and the elements below the major diagonal will be equal to 0. That is, the goal is to have something of this nature. Here you have 1, 1, 1, 0, 0, 0, then regardless of what we have on the other side. So we are going to drive this matrix in such a way that we have 1, 1, 1, 0, 0, 0. That's all. So now, for you to get 1, you can either divide a whole row by a common or a particular number to make it 1, or you interchange row 1 with row, you interchange row 2 with row 1 as the case may be. So now, we are going to start here. First of all, make this one 1, 0, make this one 0, make this one 0, make this one 1, make this one 1. So now, you interchange row 2 with row 1. If you do that, we have something of this nature. You have 1, this is row 2, minus 2, 1 dot dot 8. You have 2 minus 1, 2 dot dot 10. You have 3 minus 1, 2 dot dot 11. So what we have now, we have succeeded in getting 1 here. The next step is to have 0 here. What can you do with 2 to have 0? If you say 2 minus 2, it will give you 0. So where can you get the other 2? Now, if we say that 2 times row 1 minus row 2, that is, in essence, row 2 minus 2 times row 1. Row 2 minus 2 times row 1. Then row 1 will stand. You have row 1 as 1, 2, -2, 1 dot dot 8. Then row 3 will also stand as 3 minus 1, 2 dot dot 11. So what we are going to change here is row 2. So now this is what we are going to do. The formula is row 2 minus 2 times row 1. Row 2 here we have 2 minus 2 times row 1. 2 times 1. This will give us 2 minus 2, which is 0. So here we have 0. Then for this one, you have -1 here times 2. Look at the 2 there, times -2 times negative, that is -1 minus. Here is -1 minus -2. The formula is row 2 minus 2 times row 1. So here you have -1, this minus, look at it here, then 2 times -2. Then we have -1, -2 times -2 will give us +4. and this will give us 3. That will give us 3. So here you have 3. Now for this one, you have 2 minus 2 times 1. Look at the 2 here. 2 for row 2. Then minus 2 in the formula. Then the corresponding element on row 1 is 1. So this will give us 2 minus 2, that is 0. So this one here will be 0. Dot dot. Now for this one, you have 10 minus 2 times. The corresponding element for this is 8. You have 8 here. This will give us 10 minus 2 times 8, 16. This will give us negative 6. So what we have here is negative 6. So we are progressing. Now we have 1 here, 0 here. So the next step is to make this one too 0, so that we have something of this nature. Then to make this one 0, what we are going to do is 3 minus 3 will give us 0. So how can we get the other 3? We will say that this 3 is on row 3. You say row 3 minus 3 times row 1. Because you cannot multiply it by 0, it will still give you 0. So that is why we are moving to row 1. So to do that, I'm not going to repeat. Okay, let me just repeat this process again so that you understand. Here you have row 3 minus 3 times row 1. Row 3 here you have 3 minus 3 times, so the corresponding element on row 1 is 1. This will give us 3 minus 3, which is 0. So this is what we have. We have 1 minus 2, 1 dot dot 8. Then here we have 0, 3, 0 dot dot minus 6. Then this one here is 0. Now for this one, you have negative 1 minus 3 times the corresponding element here is negative 2. This will give us negative 1 minus, negative times negative is positive. 3 times 2 is 6. Here you have negative 1. Negative 3 times negative 2 is positive. This will give us 5. So what we have here is now 5. Then for this one, we have 2 minus 3 times this 2 minus 3 times row 1 here, which is 1. So what we have here is 2 minus 3 times 1 is 3. This will give us negative 1. So here we have negative 1. Then for this one, we have 11 minus 3 times 8. 11 minus this 3 times 8. This will give us 11 minus 3 times 8 is 24. Right, 24. This will give us negative 13. Give us negative 13. So here you have negative 13. So now we have 1, 0, 0. So the next step is to make this one 1, this one 0, then this one 1. Now to make this one 1, you divide everything here by 3. You say that row 2 divide by 3, or row 2 times 1 over 3. Because if you divide 3 by 3, you will have 1. The goal has been achieved. So now we have 1, 0, 0, negative 2. So here we have 1 dot dot 8. Then here we have 5. Here we have negative 1 dot dot negative 13. So if you divide 3 by 3, you have 1. If you divide 0 by 3, you still have 0. If you divide negative 6 by 3, you have negative 2. So the next step is to make this one 0. So what can we do to this one to make it 0? What can we do to this one to make it 0? If we say that, if we say 5, if we say row 3 minus this one 0 is 5 minus 5. Where can you get the other 5? 5 times 1. So you say that row 3 minus 5 times row 2, because you can only see 1 on this row 2, which corresponds to this 5. You cannot use this one. You cannot use this one. What corresponds to this one here is this, because 5 times 1 is 5. So now it means that your row 1 and row 3, row 1 and row 2 will stand. So you will have 1 minus 2, 1 dot 8, 0, 1, 0 dot minus 2. Then this will stand. This will give us 0. Then for this, we have negative 1 minus 5 times row 2, 5 times 0. Negative 1, look at it here, minus 5 times row 2 here, which is 0. This will give us 0, and this will still give us negative 1 dot. So here we have negative 13 minus 5 times 2, which is negative 2. 5 times this one is negative 5 times negative 2 will give us negative 13 plus 10, which will give us negative 3. This one is negative 3. Now we have succeeded in having 1, 0, 0, 1, 0, and negative 1. But we are looking for 1 here, not negative 1. So you divide row 3 by negative 1. Or you multiply row 3 by negative 1. So you will say that row 3 divided by negative 1, or row 3 times negative 1. So you will have 1, negative 2, 1 dot 8, 0, 1, 0 dot negative 2, 0, 0, 1 dot 3. So we have gotten what we are looking for. So the goal of Gaussian elimination method is to have 1, 1, 1. Then all the elements below the major diagonal should be 0, of which you have 0, 0, 0. Then you stop. When you stop, you do what is called backward substitution. With this, it shows that what you have on the first column is for x, second column is for y, third column is for z. It means that x is 0, y is 0, then on this row backward, z is equal to 1. So here you have x, negative 2 plus z is equal to 8. Then here you have y, x plus 0 plus 0z is equal to negative 2, 0x plus 0y, because you don't have anything here for y, plus z is equal to 3. Therefore, z is equal to 3. With what we have here, z is equal to 3. Then for y is equal to negative 2, because x is 0. Z2 is 0 here, y is equal to negative 2. Then you substitute y equal to negative 2, z equal to 3 in this or any of this equation to get the value of x. So if you are doing that, you have x minus 2, this one is z, y into negative 2 plus 3 will give us 8. So now let's take 8x is equal to negative 2 times negative 2 is positive 4 plus 3 is equal to 8. So now this will give us x plus 7 is equal to 8. Then x is equal to what? 8 minus 7. X is equal to 1. Therefore, x is equal to 1, y is equal to negative 2, z is equal to 3. So this is how to solve a set of simultaneous equations using the Gaussian elimination method. You solve to this extent and you have the same answers. As when you are using Cramer's rule too, you still have the same answers. If you are using matrix inversion, you still have the same answers. If you are using substitution method, you still have the same answer. If you are using normal elimination method, you still have the same answer. So the most important thing is know what you are using and know what your examiner demands of you. You solve, and in the next video, I'm going to explain to you how to solve using GAUSS-JORDAN, which is the extension of Gaussian elimination method. Thank you so much for watching. Please like, share, and comment on this video. See you some other times. Thank you.